and welcome to the SaaS developer community. I have a special guest with me today, Neha Pawar. Am I pronouncing your name correctly?
Yeah, that's right.
Yeah, fantastic. Thank you so much for being here today.
I am very excited to be here, Gwen. Thank you for having me.
Yeah, so Neha currently works at StarTree Data, where she's a founding engineer. And she joined StarTree Data because she is, I think for a long time, you've been a contributor to Apache Pinot project, right? From
That's right. Yeah.
back in Uber days.
LinkedIn days.
LinkedIn days. Oh, wow. That is. So what year did you start contributing?
I started contributing to Pinot in 2015. It was actually, I was contributing to Third Eye. Third Eye was like a little baby project under Pinot that was part of the Pinot repository. And I was actually started my career in LinkedIn on the Third Eye team, which was like this anomaly detection and root cause analysis tool built on top of Pinot. And very soon I moved from working on Third Eye to seeing, hey, how is this working so fast? So let me kind of deep dive and check out what is this Pinot under the hood. So since then, I've pretty much been contributing to Pinot.
This is such an engineering story. I was wondering, why is this so fast? If it was slow, you would be wondering, why is it so slow?
Yeah.
Like, engineers can never just take a good thing and leave it alone. So thank you. So since we are meeting in March and it is the International Women Month, one of the things I'm always contemplating is that when I have a guy on the show, they usually spend the first 10 minutes, and it would be more if I didn't stop them, just talking about how awesome they are. And previously I did this and I did that and all those things. And, you know, women normally don't do it. They don't like talking about how awesome they are. They feel they may get judged. And it is important for me to normalize women saying, really being rightfully proud about their accomplishments, like any normal human being should be. So I wanted to ask you about, tell me maybe top accomplishments that you're most proud of in your career, and hopefully it will inspire others.
Definitely. I would be happy to talk about my accomplishments that I'm really proud of. So the top on my mind would definitely be what we just talked about, becoming a top committer and also PMC on the Apache Pinot project, which is a pretty intricate and complex piece of software. And then being able to ship several important features for the Pinot community, like simplifying ingestion of unstructured data, and working a lot on the ingestion connectors and also working on the query constructs. And then most recently, a lot of complex work on the tiered storage feature for Pinot, which involved several months of trials and errors and restarting from scratch. And this is going nowhere and this is going in the wrong direction. And there was this period when I used to dream every day about tier storage concepts applied to my life, like S3 and network access and buffers. And then finally that like all paid off and we started seeing progress. It got better and better. And now it's out there in the world with a nice little write-up that I also wrote to kind of explain why we did this and what was the motivation. So definitely that's the one on top of my mind.
The part about applying the current obsession at work to my life resonated a lot. Like back when I did a lot of work on databases, I would come up with indexing schemes and partitioning schemes for everything. Like all my paperwork, every book in the house, everything we had to figure out what is the right way to index, how do we partition it, how do we make, should we be more efficient putting things back in place or pulling them out? Like it was, everything was approached from that. So yes. I can imagine applying tier storage. Do we move stuff to the garage where it's slightly slower to retrieve but doesn't take important space at home?
Yeah, something like that.
You also mentioned, like, really briefly in passing that you worked on Pinot's query layer, and I was a bit curious what you did there.
Oh, yes. So this was when I just started working on Pinot, and at that time, we used to have like PQL, we used to call it Pinot query language. And then we did this whole initiative to make it SQL and not have
Thank
all.
you. Thank you. Thank you. Thank you. This is deeply appreciated.
Yeah, and then we basically didn't want to have all these, hey, here's the little oddities where this is a database, but here's some slight differences. This query works in a slightly different way. And then here's some things that don't work at all. So we had this whole initiative where we wanted to bridge this gap, basically. And that's when, so one of the very big things that was missing at that time was order by and group by. And I got to dabble my hands in just bringing that into the Pinot query layer.
That's fascinating, especially since order by was controversial for SQL itself, because order is not a relational concept. It's only a thing users need. So clearly, if you're an academic, only the things user need is a bit controversial. Did you? Okay, you didn't share. What did you work on before Pinot?
Third Eye. Third Eye was what I was working on before
So
Pinot.
were you from more the machine learning perspective?
No, so I was building the platform for the execution of the anomaly detection jobs and making sure it's integrating well with not just Pinot, but any other backend that we wanted to plug in. So yeah.
Any older accomplishments that you want to give yourself a big shout out?
Let's see. So yes, one of them, or one other one would be lately being invited to several conferences, meetups to just share my thoughts about Pinot and basically anything that I have to say. I mentioned this as an accomplishment because I'm a really shy person and I wasn't at all comfortable with speaking publicly or just putting myself out there. And it actually all started with Kafka Summit in 2020. So my CEO, Kishore, he suggested that I apply to speak there and share what we're doing with Kafka in Apache Pinot. And I was very nervous and afraid, but I just pushed myself to do it. And I'm really glad I did. And it felt amazing because you did the keynote in that Kafka Summit. Tim Berglund did the closing note, and it felt really special to be part of that event. And after that, that kind of set the stage. And now I almost have like a speaking assignment or a commitment every month.
Oh, wow. Every month is a lot.
People want to hear what I have to say. And like, I'm here right now doing this podcast with you, which I feel is a very big accomplishment for me because you are like this really awesome role model for me. So, yeah.
And you're a great role model for everyone. So now you know why everyone invites you to their event. Yeah, no, you said two really important things. A, how important it is to have a manager who pushes you and helps you really find your next step and how to grow, like super, super important. And then the other thing is really not accepting your own limitations, like not just saying, oh, I'm a shy person and it's a fixed thing in the world that will never change and I need to build my life around that, but actually saying, okay, I'm a shy person, but what if I'll be a shy person who presents at conferences, which is pretty much how I got started, like with the idea that, okay, I could be a shy person who also, like, I don't need to change my personality. I just need to do a thing that I have to do. Just like I always give unit tests as an example. I have to write unit tests. I don't have to be a person who loves them. I don't need to be a tester. I don't, like, nothing in me have to change. It's just something I have to do. It's a job. And in many ways, speaking is, if you look at it that way, it's part of your job.
Yeah, and that's a great point. One of my colleagues here, she told me that, so what that you're a shy person, just embrace it. Be a shy person who's presenting at.
Yeah. You won't believe how many are. Awesome. So yes, thank you so much for highlighting cool stuff. Anything else you wanted to highlight, or are we good?
We're good.
Okay, awesome. So another thing that kind of touches on the whole company culture and how people work together is there was a tweet by your CEO, Kishore, and he mentioned, oh, the tiered storage features that everyone is so excited about, it actually started as a hackathon project. I brought the team in, and I guess this included you, over the weekend. And he brought in a bunch of food. There was, I think, a photo of a table with a lot of laptops and a bunch of food, and we just hacked it through. And I'm super curious, what made you take the kind of hackathon approach to start it versus, normal software engineering? We prioritize it for the next sprint and start working on it.
Yeah, that's a good question. So we had been discussing, hey, let's do this. Should we do this on and off for a while? And then we just kind of huddled to discuss a general approach with the team. And that was during the weekdays. It's not like we do everything on the weekends. And then we just wanted to kind of have undisturbed heads down time for like a consecutive chunk of hours, and then getting your CEO's undivided attention for several hours.
He wanted to be part of it.
Coding.
That's why you did it the weekend.
Yeah. So like getting a CEO's attention for coding for several hours undivided is very rare.
Yeah.
So then we decided to just like, hey, let's get together on the weekend.
No, that makes sense. So basically the trade-off was like, hey, on one hand, I'll be working on the weekend. On the other, I will have several hours of undivided coding and iteration with my CEO, which how many people in the world even do this kind of thing?
Precious time.
It is, yeah. And it helps with alignment so much, because you can kind of figure out where do your approaches differ and how to consolidate them, like in super, super fast iteration, where normal code review would literally never do it. That's really cool. And it does explain the culture. So basically the idea is that if something is important enough to be worth hours of a CEO time, it's important enough to also do on a weekend, essentially. And it seems like it should be rare. That's a very high bar. Not every feature will be like that.
Yes, that's true. And I mean, if any of the stakeholders couldn't have made it over the weekend, we would have just met over the week. And I don't really think this is, antithetical to a work-life balance. Like, I feel there's going to be a spillover from one into the other from time and again, and there's going to be things that unbalance one versus the other. I feel as long as there's flexibility on both sides, I think it's okay.
Yeah, that's kind of the key, right? I mean, if it's dual-sided, if you come and say, hey, I cannot work this week because of stuff, and this is accepted, then asking to, hey, can you work on a weekend is easier. If you feel like you have to give, but when you come and ask, it's kind of like an uncomfortable conversation, then it's obviously like, is what I'm giving here even being recognized, kind of thing. Yeah, absolutely. I'm thinking that the places where I enjoyed most giving from my spare time, or even more intensely, was where it felt like it was being recognized. Like if I give whatever I can, I will get whatever I need from the company, and there will be a lot of times I won't even need to ask. If it feels one-sided, then that's when it gets really bad.
Right. Yeah, that's a good summary. That's definitely how I feel about the culture here as well.
Yeah. So, okay, enough with the culture. I want to talk about technical things. So I've read your blog post. This is basically, so background. I've read Neha's blog post on tiered storage in Pinot. And tiered storage is obviously near and dear to my heart, because it was a huge deal when Confluent built it for Confluent Cloud, and then when we worked with the open source community to build it for Apache Kafka. And basically, my team did not work on it, but we got tons of benefits out of it. So my team did cloud native Kafka, and we couldn't have elasticity without it. We couldn't have so many things if we didn't, like, it was a performance boost. It was a lot of really great things for us. Cost savings, everything you said in blog was like, yes, exactly. So when I saw that you were doing it for Pinot, I was like, woohoo, that's exactly the type of things that excites me. So I've read a blog post and I had all those questions, which is when I pinged Neha and said, can you please join my podcast and I can ask you all those questions and it will not just be hidden away in an email chain between us. So your blog post had all those technical details supporting the performance you get and supporting the cost savings that you get, which I appreciated, but there were a lot of missing details about the benchmark itself. And I don't know, you left it out because who wants to see all those details, but what machines did you use? What cloud did you run it on? What was the storage? How many times did you iterate? Was it like the number P99 or media? So yeah, help me fill in the gaps.
Okay. So let me start with what machines were used, what was the storage. Right. So storage can mean multiple things. It could be SSD, it could be EBS, it could be an object store. And then for Pinot, there were two types that we used to already use. And that was the SSD and the EBS. And how that started was, so at LinkedIn, where we built Pinot, we operated mostly on-prem. And then we used local storage like SSDs. Then when we started StarTree, we extended Pinot to make it work for remote attached storage like EBS. And this was easy because they have the same interface, like it's remote, but it's accessible as if it's a local disk.
Yeah, exactly.
And then one key similarity was that both of these are accessible only to a single instance. So this is what we refer to as tightly coupled storage. Plus both of these have...
Can you share which EBS you picked, or is that...
that is not something I know on the top of my head.
Oh, okay.
Could have shared it.
So yeah, so this was all local, even though it was not really local storage, it was local attached storage and it behaved a lot like local storage. So
yes,
it was fairly easy for you to migrate to this.
Yes, and then because it was like local, they both have like SSD, EBS, they both will have POSIX APIs that you can access, and then you can mmap your data onto them. So this makes the data access very fast, like microseconds for SSDs and millis for EBS.
Yeah.
Now with the tier storage enhancements, we went to the next level of the storage. So Pinot can now use the object store like S3.
Okay, so when you tested either on S3 or something that is a lot like S3.
Yes, the benchmark results were on S3.
On S3, perfect.
So then S3, of course, is like very cheap comparison to SSD or EBS. But the key difference is like, it's not accessible like the SSD or the EBS. You cannot use memory mapping, and accessing from S3 adds like a network call for each access, adding like a few hundreds of milliseconds to every access compared to what we just said was microseconds or milliseconds for if you had SSD or EBS. And for analytical queries, we typically access like a lot of data segments. So it's every access is going to add that much access overhead for you. So then the question is, why did we even do this if your access, if there's a problem with the access and it's going to get slowed down? So because with the addition of your storage, we could use, of course, object store like S3. And now users are getting this option to trade off slight latency for extreme cost savings. And this was tunable beyond the retention of their choice for wherever in their whole data set. So now users have this config or option to kind of offload data from what used to be SSDs or EBS and put it onto S3 and exactly choose their cost versus latency trade-off.
Yeah, so one thing that was in the benchmark is that you actually only publish the benchmark on a single query. So we cannot really see the throughput and latency trade-offs. So in Kafka, there is a huge difference if you just slurp gigabytes or terabytes of data versus you get something very small and how long that takes. And so the big lesson for us from S3 was that the throughput was actually really good. It was only the latencies that was a problem, but that was a bit hard to see in your benchmark since it was just a single query.
Yes, that is right. It was just a single query. And the numbers that you saw was like an average latency across several single queries that were run. We do have more benchmarks, but trying to explain the motivation, introduce the concept, and show all the comprehensive benchmarks in that one blog post was getting way too complicated. So we wanted to keep this one more like an introduction and a high level teaser kind of a blog. And now we're going to have a series of blogs coming up,
Nice.
which will go into the technical aspect and also more benchmarks with the throughput component added to this.
Okay, so I'm looking forward to see all the future benchmarks that you're publishing, because there's definitely a lot more detail and depth on my workload, the type of data I have, the type of queries I have, and how this could work. Did you mention what machines did you use, or
so these were just regular EC2 instances that we use for our Pinot server component with, I think they were like the extra large or the large SKU, about 64 gigs of RAM and 16 cores.
Okay, so good, nice compute machines, lots of memory, which is probably useful when you have tiered storage, which actually brings me to the next question. So reading your CEO tweeting about it, he kind of made the whole thing look easy. He's like, oh, we just sent some things with the segments. We did it over a weekend. It was clearly not that much work involved. But obviously, like, I worked closely with the teams that did tier storage. I did not for 1 second buy that it was actually easy. So can you talk a bit about the implementation and like what things were particularly tricky for you to deal with? What parts were surprisingly easy is also a good part to share.
Definitely. So so it's interesting that you mentioned that it looked as if everything was very easy. So so I think one of the tweets in his tweet thread was, I don't know if you recall, there's this snakes and ladders with a lot of snakes. It was hand drawn. So that was kind of me summarizing my feelings about the journey of this project. So it was definitely from where I saw it and where I was, it was not just really easy to get done. And if I had to summarize what was the most challenging design part in one sentence, it would be reducing the cost while making it or while keeping it fast. So just one of these on their own wouldn't have been a challenge. But finding like this best of both worlds, like this balance, that was certainly like a tall undertaking. So I can maybe double click into both of these aspects, like reducing cost, making it fast. So then the first part was reducing cost. So like we were discussing a little bit earlier, in Pinot, we used to use SSDs or EBS. So we used to always assume that the segments are local. And then when the queries are getting executed and they come to the Pinot servers that are actually reading the segments, they always looked for the segment locally. And now we wanted to put those same segments onto S3, but we still wanted those queries to run seamlessly as if they don't care where the segment actually is. So for this, we had to create an abstraction of file system for the Pinot segments to make Pinot agnostic to where the segment was. This was both delightfully easy and a little challenging. It was easy because we were kind of surprised how well done some pieces of the Pinot segment were, that we could easily say, hey, here's a new abstraction on top of this, and now just kind of adapt the existing implementation to this. That was kind of well done already. But then the challenging part here was there were lots of assumptions in the Pinot code that had to be corrected, where we were just assuming that, hey, segment is always available locally. So kind of weeding through that and correcting all those was like a challenging part.
It's always a long tail, right? Because there's just like, okay, the first 5 things that come top of mind are relatively understood and controlled, and then there's the things that nobody remembered even exists. And last time it was touched was 2015, and
Yes, yes, I remember just running like an integration test suite, and then just, oh, this failed, oh, now that failed, oh, okay, now let's fix this, now let's fix this buffer, let's fix that index buffer. And then there was just like I mean, it was obvious because we never imagined 5, 6, 7 years ago that this is where we would be heading. So it was kind of obvious from that point of time that, hey, this assumption holds true.
Yeah, I'm thinking about, you mentioned the file system abstraction. When we did it for Kafka, there was the log abstraction, and we had to bifurcate it into local logs versus tiered logs. I'm kind of but we never added like a fake file system on top of what is essentially tiered. So did you actually create like a POSIX compatible layer on top of S3 to do it? Or?
No, so kind of similar to, I think, what you're saying about local log and tiered log. We have like a local segment and an S3 segment, and the local one just uses the POSIX APIs. The S3 one uses the S3 APIs.
Okay. So you basically kind of, I guess, created an abstraction of top of segment, and then you kind of had 2 types of segment. Yes. And then everyone else was using the segment abstraction with all the assumptions that may or may not have been incorrect.
That's right.
What was your top, most memorable incorrect assumption?
So, right, one of the most interesting ones that I remember is we kind of had to introduce this concept of fetching a segment, so kind of acquiring it, processing on it, and then releasing it. And I'll talk a little bit more about that when we talk about what we did to kind of make it fast. And then in one of our group by queries, after we were done fetching, kind of processing it, and then releasing it, and then when we were kind of merging all the results together, there was some lines of code that were assuming that, hey, the segment is still local, so yeah, I need something else from there, even though I have fetched something. So I'm just going to go and fetch it directly. And that, of course, didn't work out. So we kind of had to, in the query layer, bring this sort of discipline to some of our kind of core scatter gather operators to make sure that they stick to their boundaries of, hey, this is when you have acquired the segment, this is when it's released, so don't access it anymore.
And this is, by the way, a really good general lesson about abstractions and why they matter. Usually, if you start with an abstraction, everyone will behave, it will be enforced by the code, everyone will behave accordingly. But introducing an abstraction layer means dealing with all the places where the abstraction was missing, and therefore stuff is way more tightly coupled than it should be. I remember someone on my team, unfortunately the project was never completed because it was way more daunting than we expected. We wanted to introduce a very clean network layer abstraction into Kafka, and we found so much code that basically does, especially in testing, that kind of goes through every single class boundary and just does a lot of very random things. And yeah, it basically made introducing the abstraction layer incredibly daunting. Even though we had good reasons to want to, it never really came through. And yeah, still makes me sad. I hope one day someone will have a really good reason to do it and will be able to prioritize it. So yeah, we talked about saving cost by putting things on S3, and you want to talk a bit more about what you did to make it fast.
Right. So yeah, so after we put them on S3, had this abstraction layer. So with this, like the separation of storage and compute was kind of done. And after this separation, the query worked. So now was like the second part, the more challenging part was making it fast, because we wanted to make sure that our users who use it or use Pinot mainly for user facing analytics, low latency analytics, are still able to use it for that purpose. So if you recall from one of Kishore's tweets, the one with the screenshot and he was pointing to it, it was like a simple select star, but it was taking like more than 50 seconds.
Yes.
And that's because we had just gone from SSD EBS, which was like microseconds, milliseconds access, to S3, where each access was now taking us, giving us like addition of hundreds of milliseconds access time. So we started off with looking at what some other systems were doing, and most of them were solving this using lazy loading. So for instance, Red Panda and Druid. So the entire segment was kind of downloaded locally during the query if it's like not already available. And we didn't want to do lazy loading of the entire segment because, like I mentioned, we wanted to make sure the latencies are still good for our uh, users who kind of depend on this for user-facing analytics.
So lazy loading basically meant that a tiny read will take too long.
Yes, exactly. So like a segment can have several columns and all the indexes for all those columns. And just because you want to read something from that one segment doesn't mean you just download everything. So we had kind of eliminated that approach. And then we decided, okay, so let's take a closer look at the segment processing in Pinot. So the Pinot queries run incredibly fast when the segment is local. And then in this mode, fetching the data is combined with processing the data in the same thread, because reading the data is just so fast. But when it's on S3, and then if you access several segments, each of them is going to add like hundreds of milliseconds to
and
the
it was sequential?
So not sequential, but like let's take an example of if you had 100 segments and each segment access, if it was taking you say 200 milliseconds. So you're kind of adding 200 milliseconds into 100 if it was sequential, which it is not. In Pinot, we make use of parallelism, and then we do pipelining within each thread.
Nice.
So so let's say you have 20 threads to use for this parallelism. So even then, 100 segments, 20 threads, and then you are kind of going to add 5 times your S3 access time.
And then like if there is like a long poll, you're basically stuck waiting for the one segment that's taking too long.
Right, exactly. So then this is what we did not want to do. We didn't want that just because you're processing 100 segments here, you have to have 5 times, or based on your parallelism factor, uh, some X number of times of the S3 access. So this is where we made changes to the query layer to decouple fetching the segment from the processing the segment. This is also what I was talking about when I was giving the example earlier of introducing some constructs to make everyone aware that, hey, this is when it's fetched and now it's released. So with this decoupling of fetch and processing, we could kind of fetch as much as possible for the scope of the query in one shot before the execution part even starts. So let's say the first, in your 20 threads, the first few segments, the first 20 segments that get picked, they might wait. They would have to wait for the fetch, but everybody else should just have it ready for themselves.
Yeah, and I guess you can really plan for the order to get those segments because you have the query plan. You know, those are the things that we need now in the query plan, and those things may be important only in a bit.
So yes and no. We actually did have to figure out cleverly handling a lot of race conditions and deadlocks, because we don't quite have the order of how they will start getting executed. So we did kind of have to do some clever tricks like kickstarting it in when it was all getting fetched. But if somebody else got scheduled for executing, then making sure that that segment is not just totally stalling everything and blocking everything, or not blocked on everything else. So yeah, that one, I think this is the part that I would say was the most challenging of the project,
I
that gave
bet.
me the most dreams in.
Yeah, it is hard, and it's one of the things that is kind of hard in theoretical query optimizer ways. And like, as you see, the way you describe it, like I can imagine that you probably have three roadmap of making tiered storage just faster and faster by
Yeah.
making the query optimizer more and more aware that some data is tiered and how to approach it.
Yes.
Yeah.
And then another thing was, like, to finish this off. So again, like, even though we could decouple the fetching from the processing, the resources on the node that's doing this fetching is still going to be limited. So we already said that we don't want to fetch the entire segment. So then we kind of had to bring in, like, think about how we can really minimize and fetch exactly what we want for the scope of that query, and not fetch everything else. And be able to use the army of Pinot's indexes in this whole thing, because that's what really makes Pinot super fast. So we don't want to say that just because this is on S3, we can't use the indexes anymore.
Of course. Yes.
So yeah, these were kind of the main design challenges.
Okay, so you solved a really difficult technical challenge, but I think the reason everyone is so interested in tier storage is not because it's technically hard. That's more of the price we have to pay. It's really about the possibilities that having speed, scale, and low cost together really give you. So can you talk a bit about what it implies for Pinot use cases, and for StarTree on the cloud, and how should people reapproach their real-time workloads?
Yeah, definitely. So with tiered storage now, or maybe let's rewind to why people really like Pinot. So people loved Pinot because for their external facing analytics, for their real-time user facing analytics, it gives them like amazing low latencies. And people just want to use Pinot for everything else. Like, they wanted to use it for their internal analytics, for their ad hoc analytics and reporting. Um, and then these kind of use cases kind of bring in a lot of data and a very large retention. And uh, people can, of course, put this data on Pinot even today and use it even today. But now with tiered storage, this gives them an option to kind of say that, hey, beyond a certain point in this retention, I'm okay with lesser latency. I don't need it to be super fast. So I'm just going to tune this, adjust this, and then reduce my cost a lot. And then I can still keep everything in Pinot. So users don't have to kind of now go to these other systems that they were bringing in, because beyond a point, the cost was getting too much for them.
Oh, it's interesting. So it's not even just about the cost of Pinot itself. It was, you basically, this will reduce the complexity of the architecture, because if what you really wanted is Pinot, but now you have to do Pinot plus one more system, it's
Right.
obviously just more complex architecture, probably more operational overhead, more stuff that can page you at 3 a.m. So basically it allows you to reduce things to a single system, hopefully hosted by someone who isn't you. And this is just massively simplifies things.
Yes, exactly.
What about elasticity? Like in Kafka, this had a lot of impact for elasticity because it allowed us to add more brokers without moving terabytes of data, just the kind of live set that was still stored on the broker itself, which was much smaller. Is there a similar effect for Pinot, or is it?
Yeah, elasticity for sure. So even while I was doing the little benchmark that we published in the blog, like in a normal case, if I was ingesting and I kept ingesting and I kept ingesting data into the cluster, I would have to keep checking that, hey, have I reached the storage limit. But because I had enabled tiered storage, I could just say, hey, start the ingestion for 2 years and then let me know when it's done. I didn't have to really worry about anything. And then our compute nodes, they can just be scaled up, scaled down, come and go as needed. Users can adjust the boundary between what's on the cloud, what's in local. And basically it makes, I think, managing everything a lot easier.
Yeah, it gives you peace of mind because you don't have to worry, am I running out of storage? One less thing to monitor. And it gives you and elasticity and cost are very closely related. Like if you can expand the cluster when you need it, it means you can also shrink when you don't need it, and it actually reduces compute costs as well. So yeah, huge fan of tiered storage. Neha, thank you so much for both bringing it to the world of real-time analytics and to showing up on our podcast to explain it in more detail.
Oh, my absolute pleasure. This was really fun.
Yeah, and if anyone has more questions, post them here as responses, and maybe I can convince Neha to take a bit of time to respond to random YouTubers.
Yeah, I'll be happy to do that.
Fantastic. Thank you so much.